Welcome to The Explainer. Today, we're looking at something genuinely groundbreaking from NVIDIA research, a new AI architecture called TiDAR. And trust me, it promises to smash one of the biggest roadblocks in AI today, speed.
So, let's start with a feeling I'm sure we've all had. You ask a super powerful AI a question, and then you just sit there, watching it type out the answer, one word at a time. For all their amazing brain power, there's this noticeable lag. So what's actually going on there?
To really get the solution, we first have to understand the problem. And that problem is baked right into the DNA of the most common AI models out there, the ones running pretty much every chatbot you've ever used.
They're called autoregressive models, or AR for short. And the main thing you need to know about them is right in the name. They generate text sequentially. They come up with one word, and then based on that word, they figure out the next one, and then the next, and so on. It's this very careful, logical, step-by-step process.
Now, this super careful method is exactly why AR models are so good. They produce really high-quality, coherent text, but it's also their biggest weakness. Because they're only doing one word at a time, their speed gets stuck. It's memory-bound, which is a fancy way of saying the bottleneck isn't the GPU's raw power, but how fast it can grab stuff from memory. It just can't use all that parallel processing horsepower. Okay, so if the one word at a time method is the slow lane, what's in the fast lane? Well, for a long time, this has been a really tough choice for AI developers. You're kind of stuck with this fundamental trade-off. On the other side of the coin, you've got diffusion models, and these things are built for speed. Instead of that careful sequence, they just generate a whole chunk of words or tokens all at once, in parallel. It's kind of like the difference between giving a perfectly crafted speech and just brainstorming a ton of ideas onto a whiteboard all at once.
And this really gets to the heart of it. For years, you had to pick a side. Do you want the amazing quality and precision of a slow and steady autoregressive model? Or do you want the pure, raw speed of a parallel diffusion model, even if the quality isn't quite as good? You couldn't have your cake and eat it too.
But what if that was just the wrong way to look at the whole problem? What if, instead of choosing between two kinds of models, we could copy two different ways that we communicate?
Just think about it for a second. When we talk, we speak in a sequence, right? One word comes after another in a nice structured line. It's a deliberate process to make sure we're understood. That sounds a whole lot like an autoregressive model.
But our actual thoughts, they're nothing like that. Ideas, words, concepts, they just explode into our minds all at once. It's messy, it's fast, it's parallel, and that sounds a lot more like a diffusion model. And this is the brilliant question the NVIDIA researchers behind TiDAR really dug into. What if you could build an AI that thinks in those fast, parallel bursts, but talks with that slow, deliberate, high-quality precision? What if it didn't have to choose at all? And their answer is TiDAR, which literally stands for Think in Diffusion, Talk in Autoregression. It's a brand new hybrid architecture designed to give us the best of both worlds, not by switching back and forth, but by doing both at the exact same time.
So here's how it works, and this all happens in one smooth, continuous process. First, on the left, it thinks by using a diffusion approach to draft a whole block of potential words in parallel. It's brainstorming. Then, in the middle, it talks by using that high-quality autoregressive logic to check that draft and pick the best path forward. But here's the absolute genius part. While it's validating block number 1, it's already pre-drafting block number 2. Okay, but how on earth can it do all of that at once without just slowing everything down again? Well, the secret is this really cool quirk of how modern computer hardware works, something they call free token slots. What this graph basically shows is that on a monster GPU like an H100, the amount of time it takes to process just one single word is almost identical to the time it takes to process a whole batch of them, say 16 or 32. It's like paying for a whole delivery truck whether you're shipping 1 box or 30. TiDAR is smart enough to use all that free extra space in the truck to do its drafting and validating work, all without really adding any extra time. It's just incredibly efficient.
All right, so the theory is brilliant, it's super elegant, but does it actually work in practice? Let's check out the results. The numbers are, well, they're pretty staggering. For an 8 billion parameter model, TiDAR cranks out 5.91 times more tokens per second than a comparable high-quality AR model. That's not just a little better, that is a massive leap forward.
And this graph just shows it also perfectly. You've got quality going up and you've got speed going to the right. See how all the other models are kind of stuck in the corners? You get quality or you get speed.
But look at TiDAR, that star way up in the top right. It's just living in that perfect sweet spot, delivering both high quality and high speed. It breaks the trade-off.
Let's look at a really tough test, a math problem benchmark. The standard AR model is super accurate, almost 82%, but it's slow, just 1 token per step. The pure diffusion model, the quality drops off. Now look at TiDAR. It scores almost the exact same for quality as the best model, but it's generating over 8 tokens in a single step. That's the whole system working in perfect harmony.
So the performance is clearly there. But what does this really mean for us, for the future of AI? What doors does this open?
This really matters because it could totally change how we interact with AI. We're talking about real-time AI assistants that can actually keep up with a normal conversation, no more awkward pauses. It means AI can tackle bigger, more complex problems way faster. And by being more efficient, it makes these powerful tools cheaper and more accessible for everyone to run.
In the end, it all comes back to this one beautiful, simple idea. TiDAR combines the wild, parallel brainstorming of diffusion for its thinking with the precise, high-quality, step-by-step nature of autoregression for its talking. And that leaves us with this huge, fascinating question to think about. For the first time, we have an AI that starts to work a little bit more like we do. By completely getting rid of that old choice between speed and quality, TiDAR doesn't just make AI faster. It could unlock a whole new generation of applications, bringing AI one giant step closer to creating and reasoning at the true speed of thought.